Hello everyone, welcome back for another lesson. In this lesson, we will be looking at practical questions relating to the Kirchhoff laws. So we'll be looking at circuits and we'll be solving for the missing values. Before we do so, let's refresh our memories. So here are the laws we looked at. So first of all, this one will be handy. R is equal to V over I. So this one is going to be your probably go-to equation. It's very, very simple, but very, very useful, as you will see. In series, the resistors add up to give us our equivalent. The current is the same everywhere, and the voltages add up, the potential differences add up to give us the total voltage coming out of the power source. In parallel, to find R equivalent, we have to do 1 over R1 plus 1 over R2 and so on and so forth. The currents, the partial currents add up to give us I total, and the voltages, the potential differences are the same everywhere. Okay, so what I would like you to focus on or keep in mind are that in parallel, voltages are the same everywhere, and in series, currents are the same everywhere. The readings should all be the same. That's going to be very useful, as you will see. So let's begin with the series circuit. So let's say we are given this as a circuit with all kind of info. What do we do with this? Well, first of all, the first thing I would do is list my information. So you have R equivalent, V total, I total. So this is the power source. You have the info for the first resistor, second resistor, third resistor. And then you fill out the info based on the info provided in the diagram. So I have the value of R3, for example. I have the value of R2. I have V1. And I have I1. Okay, so I can fill this information out in my chart over here. The very first thing you should do is actually look for the amperage. If you see something in milliamps, you need to convert that right away into amps, because these rules work with amperage, with amps, not milliamps. So if I divide 200 by 1,000, because I know there's 1,000 milliamps in 1 amp, I will get 0.2 amps, which is what I wrote over here. Okay, so once I've written all my information down, the next step would be to say, okay, what is always equal everywhere in a series circuit? Let's start with the easy stuff. I know my current is always constant because there's only one pathway. So it's always the same electrons traveling around the loop. So no matter where I measure my current, whether it's at the first resistor, the second resistor, the third resistor, or at the power source, it should always be the same current. I know in your diagram there's only one ammeter, but it doesn't mean that in reality you couldn't move it and measure over here or here or anywhere at all. So that ammeter should be giving me the same reading everywhere. Since I have one reading already, I have A1, well then, knowing that current should be the same everywhere, this value should be 0.2 amps. This value should be 0.2 amps. And this value over here should be 0.2 as well. Now, having this, I now have 2 out of 3 pieces of info for the first resistor, same thing for the second one, same thing for the third one. So my next step would be to find the missing values. So I know, as I told you before in the previous slide, I know that R is equal to V over I. So I said that's going to be our go-to equation, very useful. I can also put another variation, R times I equals to V, right? If I take this and I bring it over, I reorganize my equation, I get R times I is equal to V. So R1 is equal to 12 divided by 0.2. That gives me 60 ohms. Over here I have V2. R times I will give me V2, and that gives me 2 volts. Here I'm missing the voltage, so 20 times 0.2 will give me 4 volts. Okay, what am I missing now? I'm missing R equivalent and I'm missing V total. I know that in series, my potential differences should add up. So 4 plus 2 plus 12 will give me 18 volts. And I know that in series, my resistors should add up to give me R equivalent. So 20 plus 10 plus 60 will give me 90 ohms. Now I could verify, I could prove this, verify that my numbers are correct. How would I do that? Well, I just found my R equivalent by adding up these values, but I could have also found it by doing V over I. So if I do 18 divided by 0.2, I will also get 90 ohms. So then I know that all my numbers are correct, since no matter which way I calculate my R equivalent, whether I use V over I or whether I add my resistors, I get the same value. That proves to me that all my other numbers have to be correct. Okay, so that's one way of proofing your work. Secondly, I would suggest, until you know these equations by heart, so these, until you know these by heart, you should have a memory aid in front of you. Keep a sheet like this one in front of you with all the equations. Ultimately, you should know them by heart. It's going to save you time, and you're going to be able to process the information more quickly. But at first, maybe you'll need to have this memory aid. Okay, so moving on to the parallel one. So here's an example of a parallel circuit. So I did the same thing. I recopied my information underneath here. I did not label my resistors. I should have put R1, V1, I1, and so on and so forth, but they're more or less under each section of the circuit, so you'll understand that these values are associated with this resistor, for example. Okay, so once I've recopied everything, second step, which one of the following, resistance, voltage, or current, which one is always the same throughout a parallel circuit? You should answer voltage. Now, there's a problem. I don't have any value for voltage, but I can find this one because I have R and I have I, or this one, same thing. So let me start with that. R times I gives me V. So 6 times 1 gives me 6 volts. And here I'm going to have also 6 volts. And it makes sense because the voltage is supposed to be the same everywhere. So that means I now know that this is 6 volts, this is 6 volts, and this is 6 volts as well. Now that I have 2 out of 3, I can solve for the missing current over here. So V over R, right? Because if I have R is equal to V over I, that means I would go here and R would go at the bottom. So V over R equals I. So I would have I is equal to V over R if I rearrange my equation. So V divided by R, so 6 divided by 12 will give me 0.5 amps. And this one as well will be 0.5 amps. Now I know that in a parallel circuit, my amperages my currents will add up, my partial currents will add up to give me my total current. So 1 plus 1 plus 0.5 plus 0.5 gives me 3 amps. So the only value that's missing is R equivalent. I have two choices. I could do V over I, or I could do 1 over 6 plus 1 over 6 plus 1 over 12 plus 1 over 12, and then find 1 over R equivalent, and then find R equivalent. I don't know about you, but I find that's a lot of work. If I can just do V over I, I'll just do V over I. So 6 divided by 3 will give me 2 ohms. But since I have a little bit of time on my hands, I'd want to verify if this value is correct, and therefore if my other values are also correct. So I could do the 1 over 6 plus 1 over 6 plus 1 over 12 plus 1 over 12, find 1 over R equivalent, and then flip that and get just R equivalent. With the calculator, it's much faster, so I do encourage you to do it to verify if you get 2 ohms, again, by using the other technique. And you do. So this has now verified that this value is correct, and obviously the other values have to be as well. So that's the way you would go about a parallel circuit. So I hope this helped. Most problems basically you use the same approach for all of them. It's just the numbers that change. So this gives you a structure to solve any kind of problem, whether it's a parallel circuit or a series circuit. That being said, if you do have questions, if you have a particular problem that you're not comfortable with and that you would like me to solve, I could perhaps do another little video. So send me your questions if you have any, and otherwise I will see you for your next lesson, and until then, take care.